by X. This is the average revenue. So the question is, first, it says we are given the revenue, but it says find the rate at which average revenue is changing when 81 bottles of barbecue sauce are produced. Okay, perfect. So we need to determine this. I don't want to put it here because that will not be the average revenue, but the rate of change of the average revenue. Okay, so first of all, let's determine this function, which is 7.5, x 2.7 divided by x. I copy 7.5, I copy x. Which power do I have to write here? Can anyone tell us? What is the rule? Anyone? I haven't heard from Liam yet, from Tyler, from Jessica.
Would you subtract 1 from 0.7?
Thank you very much. And the answer is?
0.3 or negative 0.3.
Awesome. This is it. Great job. And now thank you very much, Liam. So now I want to determine the average rate of change of this function. How do we do it? Anyone? Matthew, Jessica, anyone? Tyler?
Wouldn't you bring down the exponent?
Excellent.
Multiply it.
Yes, I have to do that. So I don't need to use a calculator, but 7.5 times 0.3, 2.25. Okay, so what do I write? Anyone? Jessica, are you with us? Jessica? Tyler?
Would it be negative 2.25 to x to the power of negative 1.3?
Awesome, brilliant. Thank you. And now they're asking us to plug in 81. Great job. So this function at 81, so I'm going to just write it like this. And it's negative 2.25 times 81 to negative 1.3. That's it. Negative 2.25 multiplied by 81 power in parentheses negative 1.3. And I got approximately negative 0.00743. Measurement unit. So this is dollars per unit, right? Per unit. So this is in dollars per unit squared. Any questions? This was 56. Very good pick.
I have a quick question.
Sure.
How did you get from negative 0.3 to negative 1.3?
Okay. X to power n prime is n times x to n minus 1. So when I bring the power in front and multiply by this number, I have to subtract 1 from the power. From negative 0.3, I subtract 1, I get negative 1.3.
Got it. Thank you.
You're welcome. Good. Anything else? Do we want to look at maybe average profit? So let's talk about average profit because we did talk before about average profit. So let's also look at this and move on. So we have the cost function, 4,300 plus 2.1 x 2.6. And we have the revenue function, which is 65 times x to 0.9. Find the rate at which the average profit. So again, the average profit will be P of x over x. This is the average profit. Okay? Is changing when x is 50. Good. So first of all, if you remember, can anyone tell us how do we calculate the profit if we have the total cost and the total revenue function?
It's cost, no revenue minus cost.
Very good, awesome. Revenue minus cost, excellent. So let's determine that and also put x in the denominator. Very good, awesome, thank you. So the profit divided by x, which is the average profit, will be the revenue minus the cost divided by x. Revenue, 65 times x to 0.9 minus, remember, 4,300 minus 2.1 times x to 0.6 divided by x. Because we have to subtract all terms that are in the cost function. And that's what we do. Okay, so then at this point, what I would like to do is separate this fraction because the denominator is just one term. I can write it as 65x to 0.9 over x. And how much is 0.9 minus 1? Minus 4,300 times x to negative 1. And minus 2.1 times x to 0.6 minus 1, which is x to negative 0.4. Do we understand this step? It's okay if you say no, show me again, I will show again.
Why did you do that?
Very good, because it's easier to differentiate. Perfect question. I don't want you to use the quotient rule if I only have one term in the denominator. Perfect question. So I'm allowed to separate it into three fractions. This over this is this fraction. This over this is this fraction. This over this is this. And now it will be much easier to differentiate. Other questions about this before we differentiate? Anyone else? Are we okay? So I will bring down negative 0.1 and I get negative 6.5 x to negative 0.1 minus 1, negative 1.1. I bring down negative 1 and I have positive 4,300 times x to negative 1 minus 1. I bring down negative 0.4 and I get positive, so this will be 84.084 x to negative 0.4 minus 1. And now here I will replace x by, I think it was 50, yes. So I will replace it by 50. Ugly function, but I have no choice. So negative 6.5 multiplied by 50, in parentheses the power negative 1.1. And then plus 4,300 times 50 raised to power negative 2. I like parentheses. Okay. Oops, I didn't mean that. I meant this. And then plus, oops, plus 0.84 times 50. And this time 50 has negative 1.4 power. And enter. So this is 1.6356. Any questions so far? Any questions? Okay. It needs practice. It looks maybe difficult, but if you practice these problems, you're not going to have any difficulties. I guarantee you. Okay, so I would like to continue with 1.7, which is what Nick was asking about today, what is called the chain rule. Notice that all these had just plain x everywhere. When we had to differentiate, plain x, plain x, plain x. But the question now is, what do we do when we have a function like 4x squared minus 3x plus 1 raised to the 5th power, and we are asked to differentiate this? So this is what it's called the chain rule. One inside the other, and so on and so forth. It's a chain. Well, this is what we call the inner function. This is the outer. How do I know? If you ask me to evaluate this function for x equals 0, I cannot do this power first. I cannot do anything to this. I have to perform the operations. I have to plug in 0 and calculate this number first. So that's why this is the inner function, the first one that is applied to 0. After I finish and I get a number, then I will raise this number to power 5. So that's why this is the outer function, or the second function if you don't want to use the word outer. So if this is the first function, this will be the second. Can I have more than 2? Of course. I can have e to x squared plus 3x, everything to power 4. This time I have, this is the inner, this is number 1, this is number 2, and then I apply e to that power, and this will be number 3. So I can have as many as you can think of. So the inner and the outer. Okay, what do we do with this? Once we establish which one is the inner and which one is the outer, so here is how we are going to differentiate a function inside a function. So if you remember, we used to write it like this: f cum g of x, which is f, the outer, g, the inner. Outer, which would be 5, power 5 here, and the inner, which would be in my example 4x squared minus 3x plus 1. So now how do we differentiate this? That's the question, and that's the chain rule. So if we have a function of a function and we differentiate, we start with the outer function, f prime of this, that doesn't change, multiply by the inner function prime. So coming back to our example, the 4x squared minus 3x plus 1 to the 5th, and we want to differentiate this, and we're going to follow the steps. Not before, I want to just say something here on the side. When we have x to the 10th power prime, I have 10 times x to the 9th. To be exact, I should have written times x prime. But how much is x prime? What does x prime equal to? The slope of x, 1. That's why we omitted this part. But to be exact, we should have put it in. Well, that's what we are doing here. So according to this rule, same thing, bring 5 in front. Copy 4x squared minus 3x plus 1 to the 4th power. So this is this. I differentiated something to power 5. 5 times this to 5 minus 4. So this is exactly this piece. This piece is here. Now times the inner function prime. Can anyone give us the inner function prime? And that's it.
8x minus 3.
8x minus 3. Thank you very much. That's it. And that's the chain rule. So that's why I recommend the shortcut for square roots. So the square root of a function, one more time, now we can write it, is, so of course this is a combination with power rule. So this is 2, the square root of f times f prime, of course. So now we had, Nick was asking about the square root of 2x plus 1. How do I find the derivative without using the long definition and the only definition? All I have to do is replace f, and f prime here. That's all, and this is it. So I will have 1 over 2, the square root of 2x plus 1, multiplied by the inner function prime. This is the inner function prime. What is the inner function prime?
2.
That's it. And you can simplify these two. So the final simplified form is this. And now you can check any function that you determined the derivative for before, right? So remember, we started with a function like 2 over x prime. We had to use the definition. We were asked to do that. I would have changed this into 2 times x to negative 1 prime. I bring negative 1 in front, and I subtract 1 from the power. This is just it. That's it. And just rewrite it back into the correct, or the no negative exponents form. But we had a much longer process because we were asked to use the limit of the difference quotient. And look, it took us, 3 rows. And this is just straightforward now. Okay, so now let's choose whatever you feel like it to practice this. So this is, where is on my page here? Starting from 163. Okay, let me find my keyboard. 163. Okay. So all these functions require the chain rule. Require the analyzing an inner function, an outer function, making sure that we differentiate correctly. You choose, and then I will.
Can we do number 12?
Number 12, with pleasure, of course.